We're looking at a mechanical energy question from the grade 10 November 2016 examination. A woman is at the shopping mall 10 meters above the ground. Her cell phone with a mass of 0.01 kilograms falls and hits the ground at a speed of 14 meters per second. So here at the bottom, the speed is 14 meters per second. The mass of the cell phone is 0.01 kilograms. And they want us to first convert from meters per second to kilometers per hour. Now this is a rather unusual because usually they would give us kilometers per hour and ask us to convert to meters per second, because we know that meters per second is actually the SI unit. But they were just testing to see if you read the question correctly and if you are paying attention. So we know usually if I've got kilometers per hour and I want to convert to meters per second, I would divide by 3,6. So if I'm going that way. So if I'm going from meters per second to kilometers per hour, I would do the opposite. I would multiply by 3,6. And when we put that into our calculator, 14 times 3,6, we get 50,4 kilometers per hour. But now remember, in our equations we have to use the SI unit, so we actually need to use the 14. This was just a question to test our conversions. 5.2, define the term kinetic energy. And we know that kinetic energy is the energy that an object has due to its motion. They now want us to calculate gravitational potential energy. We know the symbol for gravitational potential energy is EP, at a height of 5 meters above the ground. So let's go back to our sketch. This cell phone is falling, and they want us to calculate at a height of 5 meters above the ground. So somewhere here, 5 meters, we have this cell phone. And to calculate the potential energy, we use our equation mgh. We know that the mass is 0.01, g is 9,8, and be very, very careful when you substitute h. H is always height above the ground. And the question said 5 meters above the ground. So we substitute 5, and that would give us an answer of 0.49 joules. So at this point, its potential energy is 0.49 joules. And remember, you would get a mark for your correct formula, provided that you substitute correctly, or provided that you attempt a substitution in the next line. So for all correct substitution, you would get the second mark, and your final answer with the correct unit. And we know that energy is measured in joules. Calculate the velocity of the cell phone at a height of 5 meters above the ground. So we are still working at this point. So I'm just going to redraw this. We've got everything happening or starting at 10 meters above the ground. And then they're asking us questions that are somewhere here at a particular point, 5 meters above the ground. And then now we know that the potential energy at this point is 0.49 because we calculated it. And they want us to find the velocity at this point. So what we're going to use to answer this, especially when they say ignore the effects of air resistance. So this means that there's no friction, and it means this is a closed system or an isolated system. So sometimes in the exam they would tell you ignore effects of air friction or ignore the effects of air resistance. Sometimes they would tell you there is no friction. Sometimes they would say it is a closed system. Sometimes they would say it's an isolated system. All of that means the same thing. And we know a law regarding energy, that in an isolated system, total mechanical energy is conserved. Now let's just talk about this for a while. What is mechanical energy? Mechanical energy is made up of kinetic energy, EK, plus potential energy, EP. And the law of conservation of mechanical energy says that if there's no friction, then the mechanical energy is conserved. So that means at any point, my mechanical energy here at the top would be equal to the mechanical energy at the bottom. So let's just give, if I had to say this is the top and that is the bottom, and this is a point let's call it a point 5 meters above the ground. At every single point, the mechanical energy is constant. If I take the kinetic energy at that point, and I take the gravitational potential energy at that point, and I add them, I would keep getting the same mechanical energy at any 2 points. So I can start off by saying that the mechanical energy right at the top is equal to the mechanical energy 5 meters above the ground. Now, why am I not using the bottom? Why am I using 5 meters above the ground? Because the question wanted to know the velocity 5 meters above the ground. Now, we know that mechanical energy is kinetic energy plus potential energy. So the kinetic plus potential at the top is equal to the kinetic plus potential energy at 5 meters. So at the top, a woman is at the shopping mall 10 meters above the ground. Her cell phone falls. So initially, her phone was at rest. It had 0 kinetic energy. And at the top, it's got a maximum potential energy because it's so high above the ground. It's 10 meters above the ground. And remember, potential energy is mgh. So the greater the height, the greater the potential energy. So the potential energy would be her mass, m, the cell phone's mass, times g, times the height above the ground, because we're working with mechanical energy at the top. So we take the height at the top. And this would be equal to the kinetic energy 5 meters from the ground. And we know the formula for kinetic energy is half mv squared. So we can say half 0,01. We don't know the velocity at that point. That is what we're trying to calculate. However, the potential energy at 5 meters we had calculated in the previous question. mgh, we used the mass, 9,8, and 5 meters for the height, and we ended up with 0,49. And when we solve for v, we would get an answer of 9,89 meters per second. And that is how you would go about attempting a question like this. When you see that there's no air friction or no friction and it's a closed system, you would use the law of conservation of mechanical energy. And that says that E mech at any point is equal to E mech at any other point. So this time we took the top because we had information about the top. We knew that the initial kinetic energy was 0. And we also knew the potential energy at the top could be calculated because we had the height above the ground. And we used mechanical energy at 5 meters because that's what the question was requesting. And we end up with an answer of 9,89. And the last question, will the value of the cell phone's mechanical energy just before it hits the ground be greater, less, or equal to mechanical energy at a height of 5 meters? And that is for 3 marks. So we're going to say equal, and the reason why, so that's your first mark, and the reason why it would be equal would be it is an isolated system, therefore mechanical energy is conserved. Energy is conserved. So we are using the law of conservation of mechanical energy to answer that question. I hope that you found this video beneficial. Please like if you did, subscribe so that you don't miss future videos, and share this video with as many of your friends as you can so that more learners can benefit from these lessons.